Okay, today we're going to start discussing the electric field worksheet. So I'm not going to follow any particular order. I'm going to follow based on which questions students have got the lowest marks. So let's start discussing with question number 9. So if you haven't read the question, please pause the video and read it. The issue here is not related to electric field directly. It's rather about how to determine the potential difference between the two plates. We know that the equation, as far as the equation is concerned, that's easy. E is equal to V over T. That's the equation that we're going to apply. But the issue is how we are going to determine the potential difference between the two plates. Now this means, this is 800 volts means, now compared to this earth, this point is at 800 volts more, right? So the potential at this point, the voltage at this point is 800 volts. Similarly, if you consider here, this is 300 volts, so the potential of this plate is 300 volts. So the potential difference between, say this is A and B, so the potential difference between A and B would be 800 minus 300, 500 volts. Now these things in detail we will study in the DC circuits, the next topic, but like you can make it out from your common sense or GCSE knowledge that okay, this is at 800, it is like this. How can I put it? Okay, there is a common ground, so both of these are connected to earth. Then this one is kept at 300 volts, this is kept at 800 volts, so the difference is 500 volts. Or you can think like this, from the very basic definition of voltage, potential difference. It is the energy gained by 1 coulomb of charge when it goes from one point to the other. Energy transferred, right? Sorry, not gained, energy transferred. So when if 1 coulomb of charge has to go to this point from here to here, it needs 800 joules. That's like the ticket price. And if 1 coulomb of charge needs to go from here to here, it needs 300 joules. That means if it needs to go from here to here, it needs another further 500 joules, right? So you can look at it conceptually like that, or you can think this is 800, this is 300. So the difference should be 500, and that's the potential difference. So once you have found the E value to be 500 volts, then the rest is easy. You have, not E value, the voltage value is to be 500 volts. Then calculating the E, so there is a proton in between, and they're asking you to calculate the acceleration of the proton. So if you want to calculate the acceleration, we can only use F is equal to ma at this moment. So F over m. Now the mass of the proton, it will be given in the exam paper, so we will find that out. But finding the force, now the force would be equal to electric field strength time charged. The electric, there are two equations we learned in electric field. One is E is equal to V over D, the other is E is equal to F over Q. We have wrote these equations many times while doing the structures. So acceleration equal to F over m. The force is the electric force, so EQ from here over m. So charge of the proton, that's the charge of the electron, you can get it from the exam paper. Mass, you can get it from the exam paper. Now the electric field strength, that's the only thing we need to calculate, and to calculate it we need the potential difference. It's given the separation of the plates is 20 centimeters, so that's no issue. So if you substitute correctly, acceleration, so first we will find the electric, we will just substitute everything together. So electric field strength is V over D. Again we have Q and M. So basically the acceleration is VQ over dm. So voltage, as we calculated, 500 times the potential, charge, 1.6 into 10 to the power minus 19. Then the distance between the plates, 20 centimeter, 20 into 10 to the power minus 2. And the mass of the proton, so you could just open up any past paper and it will be given in that data sheet. Just a moment. So mass of the proton, 1.67 times 10 to the power minus 27 kilograms. So if we put these values in, 500 division 500 times 1.6 times 10 to the power minus 19 divided by 20 times 10 to the power minus 2 times 1.67 times 10 to the power minus 27. That's 2.3, so that's 2.4 times 10 to the power 11 meters per second squared. Okay, 2.4 times 10 to the power 11 meters per second squared. But there are two answers with that value. One is downward, the other is upward. So this is a proton. Now the top plate is comparatively positive than the negative plate, so the electric field, as you know, will be in this direction. It will start from a positive charge to a positive terminal and ends in the negative terminal. So this is a positive charge, so it will move along the direction of the electric field. So it would move at 2.4 downwards. So ninth question answer is A.